Hey everyone, thank you so much for being here. Welcome to my talk on bypassing AWS CloudTrail. My name is Frichette. I'm a security researcher over at Datadog, where I work on our cloud security products. I spend a lot of time coming up with ways that adversaries can more effectively compromise and exploit AWS resources. And from that, how do we detect that behavior or hopefully prevent it entirely? As a result of that research, sometimes I find vulnerabilities in the underlying AWS services, some of which we'll be talking about today. In terms of content for this session, we have quite a lot to get through. As mentioned, we'll likely use the full 30-minute time slot. So if you have any questions, feel free to see me in the wrap-up room, and I'd be happy to answer them. Or feel free to reach out through the social media links I'll have at the end. For this session, we'll dive into just a quick recap on what CloudTrail is and why we care about it, both from a defensive perspective and an offensive one as well. Then we'll take a look at the internals of the AWS API, learn a little bit more about it, so that we can then apply that knowledge to start bypassing CloudTrail. Over time, I found a number of vulnerabilities that have allowed me to bypass CloudTrail in some way. Everything from simple permission enumeration up to and including interacting with a given service while completely avoiding all logging. Now, really quick, it's important to note that when we describe a CloudTrail bypass, this is not a misconfiguration. This is not something we can account for with our CloudTrail setup. It's not something silly like if we disable CloudTrail, now we've bypassed it. A CloudTrail bypass is very much so a flaw on the AWS side of the shared responsibility model. And as a result, it's ultimately up to Amazon to fix, remediate, or otherwise mitigate these issues. And as I'm sure you can imagine, AWS has a vested interest in ensuring the security of their platform, which, as a result, since I've disclosed these issues to them, almost all the things we're going to be talking about today have since been fixed by AWS. So think about this talk less from the perspective of, if you're a pen tester or a red teamer, here are some specific things you can do, and much more from the perspective of what can we learn from these vulnerabilities that we can apply to future bypasses. And indeed, we'll show there is still a ton of opportunity to evade detection from CloudTrail. While these specific vulnerabilities have been fixed, the high-level archetypes and categories are still susceptible. And the ones we'll be talking about today are protocol mutation, undocumented APIs, and abusing non-production endpoints. So with all that out of the way, let's get started. First, what is AWS CloudTrail? CloudTrail is a fundamental security logging service offered by AWS, and it is responsible for logging calls to the AWS API. Under most circumstances, when an identity in an AWS environment performs a call to the AWS API, that invocation will generate a CloudTrail event, which will contain all of the relevant metadata around that invocation: the identity that performed it, the date and time that it occurred, the specific API service and action, the IP address and user agent of the client, as well as all of the relevant request parameters. As a result, as you can imagine, CloudTrail is a fantastic tool for security teams. It helps answer the question of who did what when in an AWS environment. And this, combined with the log aggregation platform of your choosing, makes it very easy to do automated threat detection of suspicious activities. Now, security teams love CloudTrail, and it's very helpful, but by that exact same notion, CloudTrail is a substantial problem for adversaries. For an attacker, there is a significant draw to use stolen IEM credentials, because with those credentials, they open up the possibility for things like privilege escalation, lateral movement, maintaining persistence, accessing resources, and so much more. But they run the risk that just about anything they would do with those credentials will ultimately get it logged to CloudTrail and later on analyzed by a SIEM, a data lake, or something else, getting them caught. So this is the motivation behind the research we'll be talking about today. Adversaries want to cover their tracks as best as they can to avoid detection. And if an adversary can perform calls to the AWS API without leaving a trace in CloudTrail, they are fundamentally invisible. Security teams have no way of knowing that this activity has occurred. Now, to get started on the internals of the AWS API, it's important to note that AWS is very big on what they refer to as model-first design. And what this means is when they create a new service, before they write a single line of code, they first create a model that describes everything about that service, what its operations are, what its parameters will be, and so on. Now, this model-first design carries over well into production. And as a result, we can actually extract out the models from the AWS SDKs. What you see on the slide here is an example of the top portion of a model for the Secrets Manager service that I've pulled from the Bodacore Python library. Now, these models are important because they contain basically all the information that we need in order to start interacting with the AWS API. When it comes to things like undocumented APIs, finding these models is basically half the battle. Now, there's a lot of important information here. For our purposes today, by far the most important part is something called the protocol. The protocol of an AWS API is the format by which we will serialize our requests on the client so that they can be properly deserialized on the server. As you can see here, Secrets Manager uses the JSON protocol, specifically JSON version 1.1. There are 6 total protocols that are currently in use by the AWS API. And again, these are simply the format for our requests. So to continue our Secrets Manager example, because I know that it uses JSON version 1.1, that tells me that it'll always be a POST request. It'll always go to the base path, not like /API or anything like that. I know that it'll send its content as JSON. I know there will be an X Amazon target header, which is made up of terms from the model, as well as, for our purposes, the most important part, the content type header. Specific to the JSON family of protocols, the content type header is the version of JSON that is used. And this takes us to our first potential for CloudTrail bypass. Because the AWS API uses this very rigid, well-defined structure for its formats, what happens if we were to start mutating our request or malforming our inputs? Could we cause the AWS API to behave in such a way that is advantageous to an attacker? Well, an interesting place to get started with this is simply, if there's 2 versions of the JSON API, what happens if I send the wrong version to a particular API endpoint? For instance, sending a 1.0 header to a 1.1 API. Well, as it turns out, we got some interesting behavior. Depending on if an identity did or did not have permission to perform a certain API operation, you would get back a different HTTP response code. If it did have permission to perform that operation, you get back a 404. And if it did not, you would get back a 403. And critical to all of this, because we are malforming our input, none of it got logged to CloudTrail. And so it was through this method that an adversary could steal IAM credentials and by changing a single character in a header, enumerate whether or not they could perform an API operation completely silently, avoiding CloudTrail. And at the time, this affected over 645 actions across over 40 services. Now, for a real-world perspective on how we would use this, it's important to note that for adversaries who have gained a foothold in an AWS account, they often have no way of knowing what level of privilege they've just compromised. The keys that they found could belong to the root user and thus have access to everything in that AWS account. Or they could have literally no privilege at all. And so a common method by which adversaries deal with this situation is brute force. Try and see what works. If you perform an API call and it succeeds, you have that permission. If it fails, then you don't. And there's even a handy tool to automate this for you called enumerate IAM, which allows you to very quickly brute force what permissions you have access to. Now, the good news for defenders is that this behavior is incredibly noisy and is fairly easy to detect. It presents itself as a sudden increase in access denied errors for a particular identity, or it can also be identified through an identity performing API operations. It has no history of ever doing so, which as a result, this serves as an amazing golden opportunity for defenders to detect suspicious behavior and kick an adversary out of an environment. But if we change just a single character in a header, defenders now lose out on that golden opportunity. Because none of our activity would show up in CloudTrail, defenders have no way of knowing that this activity has occurred. And as a result, an adversary could enumerate permissions for hundreds of actions over tens of services completely silently. If you're interested in this topic, I have a ton of additional resources, information, and proof of concept scripts at that URL there. For its time, this was an incredible way for pen testers and red teamers to enumerate permissions completely silently. Next, let's talk a little bit about undocumented APIs. Undocumented APIs have been sort of a hot topic in the AWS security research community lately, as they've led to some fairly significant vulnerabilities and the potential for CloudTrail bypass. For our purposes, we'll define an undocumented API as an API that exists within AWS that does not appear in the public documentation or in the SDKs. Now, by that same notion, the question becomes, how do we find undocumented APIs? Because they are undocumented, there's no single source or way for us to really find out about what APIs AWS might have hidden. Personally, the best way that I have found has been to use the AWS console. In order for your browser to know what all options it has, how to properly sign and format these requests, your browser needs to have those very same models that we described previously. And as a result, you can actually crawl through the AWS console and extract out those models. And interestingly, the models present within the AWS console are not the same ones that appear in the SDKs. They often include internal-only and undocumented APIs. So as an example of this, there is an undocumented API called IAM admin, which is interesting aside from the fact that its name is IAM admin. One of the neat things about it is that the names of its operations sound vaguely familiar to the normal IAM ones, but not quite. So as an example, IAM admin has an operation titled list access keys for multiple users, which sounds vaguely familiar to IAM list access keys. Now again, we can crawl the AWS console, extract out through the JavaScript to pull a list of all possible operations that we can invoke against this IAM admin service. Now, from here, a common technique used by security researchers specializing in AWS is if you find a sketchy API, perform that API call with a user or role who has no permissions at all. And the reason you do this is because the relationship between the API that you're invoking and what actually gets called on the back end is not always a one-to-one relationship. So as an example, if we were to perform the IAM admin method list access keys for multiple users, and the resulting error message, we would get back the quote, user is not authorized to perform IAM list access keys. And that is a normal documented API. So it's through this method of using an undocumented API, essentially as a proxy, that we can invoke and get results from normal documented ones like IAM. Now, if we repeat that process for all of the operations that we found in the previous step, we eventually create a map between the undocumented IAM admin methods and the documented IAM ones. Now, the question here becomes, what does this look like in CloudTrail? Does it show up as IAM admin? Does it show up as IAM? Does it show up as both? Well, turns out it showed up as neither, because it didn't show up at all. None of the invocations made against the IAM admin service would show up in CloudTrail. And so it's through this method of using an undocumented API that an adversary could make calls to the IAM service completely silently and avoid detection. Now, the reason this matters is, again, this is a commonly detected behavior. A ton of commercial SIEMs have out-of-the-box default detection rules for suspicious calls to list access keys, list groups, and things like that. And even AWS's own GuardDuty, which is a managed threat detection service offered by AWS, has a detection rule for what they refer to as anomalous behavior that's designed to pick up on this exact behavior. But because none of this ends up in CloudTrail, all these tools lose out on the opportunity to see that this behavior has occurred, and attackers can operate with free rein. Now, this specific vulnerability has since been fixed by AWS. Anytime you invoke IAM admin, the IAM admin service, the equivalent IAM method shows up in CloudTrail. But due to the sheer number of thousands of undocumented APIs, it certainly makes you wonder what other APIs may behave in a similar manner. Next, let's talk a little bit about non-production endpoints. I think this is a fairly exciting field in AWS security research currently, and is the most likely to return future CloudTrail bypasses with relatively little effort. And we'll talk a little bit about why that is in just a moment. First, a quick recap on the structure of the endpoints. Typically, when you interact with the AWS API, the endpoint that you're interacting with will differ on a service-by-service basis and a region-by-region basis. And typically, the format for that endpoint is service.region.amazonaws.com. It's not always the case, but in the vast majority of circumstances, that is the general format that they use. So to continue our Secrets Manager example, if you want to talk to Secrets Manager in the US East 1 region, that would be the endpoint that you would use. Now, this is an example of a production endpoint. This is what the CLI, SDK, the console all use, and what you're expected to use. It may surprise you to know that there are thousands of non-production endpoints that we may be able to reach over the internet, and we may be able to authenticate against using our normal AWS account. Now, these non-production endpoints exist for a variety of reasons. There are pre-production environments, alpha, beta, gamma, which is a part of the AWS deployment pipeline. There's staging, preview builds, legacy, alphabetical ones, and a pretty wide variety. Now, you may be wondering, OK, there are these non-production endpoints we can interact with, but how do we actually do so? Would we have to manually sign our requests using SigV4? Well, as it turns out, the AWS CLI can be a huge help here, as within the CLI, there is a built-in argument for endpoint URL. Simply pass in the endpoint that you're interested in interacting with, and it'll work just about as well as you'd expect. Now, non-production endpoints have a ton of interesting potential for a wide variety of defense evasion purposes, including outside of pure CloudTrail bypasses. To sort of get us started here, sort of introduce the topic, I'd like to introduce the base case of KMS-A. This is a non-production endpoint that has access to production resources and does report to CloudTrail. Now, what I mean by that is if you were to interact with this endpoint, you would see all the credentials and KMS keys that you would normally see. Anything you create, modify, or delete via that endpoint will also carry over into the production endpoint. It'll appear in the console, and so on. The reason I'm being so specific that this is an example of a non-production endpoint that has access to production resources and does log to CloudTrail is because it's possible for the inverse to be true. There are non-production endpoints that do not log to CloudTrail and do not have access to production resources. So to demonstrate this, we have a little bit of a test set up. Here we're performing two AWS API calls. First, we're calling SNS list topics in the US 2 region. And you see that there is a topic. We get a result because there is one. We then perform the exact same operation, but this time against the non-production endpoint SNS-gamma. And you see that we don't get a result. It's empty. Presumably, this is because that non-production endpoint is in a siloed environment from the production environment. Hopefully in the same way that your pre-prod environment doesn't have access to your production database. Now, this is all a bit of a bummer because that non-production endpoint doesn't log to CloudTrail. And so if it did have access to production resources, that'd be great. We'd be able to interact with the SNS service completely silently, create, modify, delete things about as easily as you'd expect. But just because it doesn't have access to production resources doesn't mean it's completely worthless to us. If you'll notice, we still got back a response. It's empty, so we didn't get the resources, but we still got the successful invocation. Somewhere along the line, IEM took a look at the permissions of the identity performing this operation and said, yeah, you're allowed to do this, and let it go through. And crucially, it didn't appear in CloudTrail. We have one event showing because we performed one event totally normally. It completely misses the second one. And so it's through this method of using a non-production endpoint, very similar to what I described with protocol mutation, that we can silently enumerate permissions while avoiding detection. And this raises the question, if you're an adversary who's just stolen IAM credentials and you're trying to figure out what you have access to, why would you ever use the normal production endpoints that'll log to CloudTrail and probably get you caught when you might be able to take advantage of a non-production endpoint that does not log to CloudTrail and get yourself the exact same information? Now, for my pentest and red team friends, it's worth noting this technique still works today, not just for this endpoint, but for a variety of endpoints across a variety of services. I did disclose this technique to AWS, who responded that they're not interested in changing this behavior right now, which, as a result, makes it fair game to abuse. And in a few weeks, I intend to release a blog post with some additional details, along with the full data set of non-production endpoints that behave this way and their associated service. Next, another potential use case for non-production endpoints is something I've been loosely referring to as event source obfuscation. And to be clear, this combination of behaviors is certainly the most rare. But here's an example of it working. For our demo, we have a very similar setup to what we did before. We're performing 2 API calls. The first one is IVS list channels in the AP Northeast 1 region. And you see, we get a channel because there is one in that region. We then perform the exact same API call a second time, but this time against the non-production endpoint IVS-gamma. And you see, we get back the exact same result. So presumably, this non-production endpoint has access to production resources. Great. What does it look like in CloudTrail? Well, unfortunately, we see 2 events, so yes, it does log to CloudTrail, but it does so in sort of a weird way. If you'll notice, the first invocation that we did completely normally and occurred at the 19th second has an event source of ivs.amazonaws.com. Now, this is normal. This is exactly what we would expect from an event source for a CloudTrail event. But the second invocation, the one that used that non-production endpoint and occurred at the 25th second, has an event source of gamma-starfruit. Now, I don't know what gamma-starfruit is. I presume it's an internal code name or service name, something like that. And worth noting, not all non-production endpoints that have event source obfuscation report an event source of gamma-starfruit. Instead, by far, the more common thing that I've seen is gamma-service name, but starfruit is certainly the most interesting. Now, event source obfuscation matters for 2 key reasons. The first is it's important to note there are a ton of commercial SIEMs that use the event source as a part of their detection rule. And if there was a detection rule for the IVS service as an example, when that SIEM goes to evaluate that event against the rule, it's going to compare 2 strings, and those strings aren't going to match. As a result, you can potentially evade detection from things like SIEMs by using event source obfuscation. The second reason this matters is for forensic scenarios. It's totally reasonable to want to pull all the logs for an affected service during a given time frame. The way that you do that is by the event source. And if you were to do that for this specific example, you would miss out on the event that has the event source obfuscation. Now, the final potential use case for non-production endpoints that we'll be sharing today is there's a combination that, as I'm sure you expected, of having access to production resource and does not log to CloudTrail. And that's exactly what we saw with Service Catalog. By changing the endpoint we were interacting with, we would be able to perform both read and write operations to the Service Catalog service completely silently, avoiding CloudTrail. Now, this is especially concerning for a service like Service Catalog, whose entire purpose is to be a consolidated central location to store your infrastructure's code templates that you can then deploy out across your enterprise. Imagine a scenario in which an adversary has gained a foothold in that account with sufficient privilege. They simply could have changed the endpoint they were interacting with, and now they could backdoor or modify those applications and portfolios completely silently. As another example of this, a very similar finding for the Event Bridge service. Again, changing the endpoint we're interacting with. We still have access to all the production resources that would normally exist, but now none of it gets logged to CloudTrail. You're probably wondering, cool, how do I find these non-production endpoints? This is something that I tackled myself. I've tried a number of things, everything from just brute force, looking at subject alternative names in TLS certs, looking at passive DNS, asking AWS very nicely, before eventually settling on what I thought was the best method, which is using certificate transparency logging. There is an amazing open source tool called CertSpotter that allows you to monitor specific domains and subdomains. And what I have set up is a ton of automation that basically every time a new cert is generated, we check and see if it does actually respond similar to how an AWS API responds. And if it does, try and fingerprint what service it's associated with. And it's through this automation that we still have running. Every time it finds a new CloudTrail bypass, I hand it off to AWS so that it can be fixed. Or if it finds another endpoint we could use for permission enumeration, I add it to a little database. Now, that has been a look at all the techniques we'll share publicly today on ways to bypass CloudTrail. There is still a ton of opportunity here to find more ways and more services that can be affected. For today's talk, we took a look at protocol mutation, abusing the rigid structure and format of the AWS API to leak whether or not we had sufficient privileges. We took a look at undocumented APIs, using them essentially as a proxy to invoke a normal API operation completely silently. And then we took a look at non-production endpoints, which offers a world of opportunity for defense evasion, but specifically by changing a single endpoint that we're interacting with, we could simply ignore CloudTrail entirely. If you're a security researcher, I strongly encourage you to take a look at some of these techniques so that you can apply them to your own bypasses, or perhaps you'll find an entirely new way to evade CloudTrail. And with that, thank you so much. I'd be happy to answer any questions in the wrap-up room.